All right. Well, good morning, everybody.
Good morning.
Can you all hear me well? Okay, great. Well, welcome back. And as we have this distinguished seminar series that we are co-hosting with CIB, that is International Council for Research and Innovation in Building and Construction. And along with Purdue University, this seminar is getting broadcast all over the world. So today again, we have yet one more distinguished speaker, and we have with us Professor Dayana Costa from Brazil. Let me introduce her briefly so that then I can hand it over to her for her seminar. Dr. Dayana Costa is Dean of Postgraduate Studies and Associate Professor of the School of Engineering, Department of Structural and Construction Engineering at the Federal University of Bahia in Brazil. She has a PhD in civil engineering and construction management. She has industrial experience in the Brazilian construction sector and the international experience in research. She was a visiting researcher at Salford University as well as Georgia Tech. In 2008, Dr. Costa joined the Structural and Construction Engineering Department of the School of Engineering at the Federal University of Bahia in Brazil. Her research area involves construction management, especially lean construction, production management, performance measurement, and benchmarking, and sustainable management in construction, focusing on reducing environmental impacts on construction sites. Currently, she focuses her research on integrating digital technologies into the construction management process. Since 2009, Dr. Costa has been the principal investigator in several research projects in the Brazilian government agencies and industry partnerships that funded those research. As a result of these research projects, she has extensively published her work, written a number of book chapters, conference papers, and so on. And so far, she has supervised more than 25 doctoral and master students. And we have one of her PhD students is here, Luara Fernandez. She's a visiting scholar here, and many of her students are also signing up from different parts of the world. So please welcome Professor Costa.
It's on. Yeah. Hello, good morning, everyone. Thank you so much for this invitation, Mark. Thank you for the invitation. For me, it's an honor to be here, see this full house of students, to see the audience, the online audience, just to see what's going on in our research in Bahia. So thank you again for hosting us, and I hope that you enjoy what we have to present. So the idea today is to talk about smart construction, application of digital technologies for construction site monitoring. But before this, I would like to introduce myself. Dr. Hastak already done this, but let me talk a little bit about my work. So my name is Dayana Costa. Nowadays, I'm the Dean of Graduate Studies in Brazil, in my university. There is a little bit difference between my job and the Dean of Graduate Studies here in the US. In my university, we don't have the deans at the schools or college. We have one dean for the whole university. So nowadays, I have to deal with 86 graduate courses, graduate programs from different areas. It has been a very, very important experience for me because now I can understand a little bit about from arts to any other animal science and so. But my role today is not as Dean of Graduate Studies. My role here is to show a little bit about our research in Brazil, especially at the Federal University of Bahia. So a little bit of my city. I don't know if you are aware about this, but this is the Brazil map. And my city is the Salvador city. We are just here in the coastal area of Brazil. Salvador is in the northeast of Brazil. We were the first capital of Brazil in 1500 something. We have a beautiful coastal area. To have an idea, we have 52 kilometers of beaches in our city, and we have a lot of African descendants in our city. So 80% of our population in Salvador and in Bahia are from Black people. So this is why we have strong connection as well with Black colleges here in the US, because we have several issues in common. So UFBA is a very well-known university in Brazil. We have around 70, 80 years now as university, but we had in the past colleges like the School of Engineering, the School of Medicine. They were established in 1886, 1808, something like that. So we have history of this, but the university is quite new. But we have a lot of courses and we have a great numbers in our school. So we have around 102 undergrad courses from different areas, around 45,000 undergrad students in our university. It's a huge amount. In terms of graduation programs, we have 150 courses that are together in 86 programs, different programs. And we have around 8,000 students in the level of graduate studies. We have around 3,000 faculty staff and 3,000 administrative staff as well. One of the missions of the Federal University of Bahia is to be a the unique site. We have this unique site of education for human resource and knowledge production, but focus on returning to Bahia society the problems that we face daily regarding social, racial, gender inequality. So most of our work, we are trying to provide solution for our local problems as well, okay? And this is the School of Engineering, the school that I am the associate professor. We have 11 undergrad courses from different areas: civil engineering, electrical engineering, computer engineering. We have 6 PhD courses, 6 academic master courses. We have 2 professional master courses. We have around 5,000 undergrad students in our school and 1,000 grad students in our school from these different areas of engineering. And finally, this is the research group that I am the coordinator. Our research group is the research group of construction management and technology. So at the beginning, our main focus was lean construction, foundation, performance measurement and management, sustainable construction. But in the last 8 years, 8 years, we are focused our research also in the introduction of digital technology into the construction management process. So we are much more interested now how we can develop this construction, how we can improve the construction management process, but using digital technology, integrating this digital technology in order to provide better information for managers to make their decision. One important thing of our group, we have a close relationship with the industry. So I can say 99% of our works, PhD and master investigations, are on the construction site. So they shouldn't go to the site and develop their research there. Data collection, based on observation, interview, intervention, and so. So this is why we have a very important opportunity in our research group to understand what is going on in the construction site, understand how our artifacts are affecting the process, and we have the opportunity to understand the capabilities needed to introduce these artifacts into the management process. So I think this is the key strength of our group, to have this close relationship with the industry. And we are definitely trying to do something for them, that we can find the impact into the construction site. Our group is formed by 4 faculty professors, 1 postdoc, Rose, my super postdoc that helped me a lot, mainly now with this new role in the administration. 6 PhD students, Luara is one of these students, she's here, 2 master students, and 11 undergrad students. In Brazil, we have a huge program since the 80s that we want to introduce the undergrad students into the research area in the early stages of the courses. So we have scholarships in Brazil to add the undergrad students to our research. They are really, really important. They are the guys that can develop softwares for us. For example, I'm a civil engineer, and I will show you some of our works that are related to automation, development of algorithms. Without the undergrad from electrical engineering, computer engineering, we were not able to do that. So these undergrad students are essential in our work because they develop several things. And as Luara once was an undergrad student of mine. I think she was in love for the academic field, and then she started to develop her master and PhD. So this is the way that we do in Brazil in order to introduce very early the students to our research field and the environment. So let's start to talk about the work that I'm here to present. So the idea is to talk about some specific projects that we have in our research group, and it's pretty much related to the introduction of different digital technology into the construction management process. As a background, what we can see, construction industry, it's a very powerful industry around the world. We represent 13% of the GDP of the world. We have a huge representation, but many books, if we read books and magazines, we can see that the productivity of our sector is behind the productivity of the industry in general. So this is a data, it's from February 2017, saying that 13% of the GDP represents activities related to construction, but we are just increasing 1% per year in the last 20 years in terms of productivity. So this is why we think that the digital technology can enhance this productivity of the sector, and we need this. This is something that is really important. So the idea to integrate technology into construction management, it's exactly for this, to enhance productivity. In this sense, what we are trying to think, we developed several works trying to introduce the technology into construction site, but we are trying also to develop some concept, which kind of, what is the future of the construction for us? We are talking a lot about construction 4.0 nowadays, lean construction 4.0, industry 4.0, industry 5.0, and we are trying, specifically in Luara's work, understand how this can fit together. We know that there are several names for this digital revolution, but we are trying to understand how we can name these in our works. Doesn't mean that this is the best concept, but this is the one that we are trying to use. So we are calling all of these as intelligent construction environment. Why? Because we are using the foundation of Industry 4.0, Construction 4.0, some principles of Industry 5.0 to understand that, to define that this intelligent construction environment is an efficient, resilient, and human-centered and sustainable environment composed by a complex social technical system that use technology as tools for continuous improvement. What I want to say that in construction, we have a huge complex system. We cannot consider just the production process. We need to consider the people. We need to consider the culture. We need to consider the work infrastructure, mainly to introduce this technology. So we need to consider the digital technology. So we need to consider several elements that what we are calling a social complex system. And we are using several principles from this Industry 5.0, 4.0. For example, Industry 4.0, they focus on technology, the introduction of technology, basically. But we are observing and seeing in our work that people is crucial. Process is more than crucial. So we cannot only put a technology into a construction project or site and expect that it work. It will not work. So we need to consider people, process. We need to consider this resilience of this process as well. So this is why we are putting all of this together in this concept, intelligent construction environment. Luara is the one responsible to refine this concept in her thesis, and we will try to develop a little bit more. And why I'm talking about this intelligent construction environment? Because most of our work are embedded in this environment. Our studies are related to construction site. So we look at the execution of the construction. So this is why we are talking about construction environment. We expect that this construction 4.0, lean construction 4.0, this concept of intelligent construction environment impact a lot in the construction industry. What kind of impacts? We need to be a more innovative environment. We need to improve, we require a lot to improve the sustainability of our construction industry. We need to save cost and time. We need to enhance safety. We need to enhance the quality. We need to improve collaboration and communication. So all of these impact, we are trying to measure in some way in our work. So the only way that we can say what we are developing in our work is working for the industry is to see if the technology or the system or the protocol or the method that we are developing are impacting some way in these aspects. But we have challenges. We still have loads of resistance to change in our industry. This is not easy. We have unclear value proposition. Sometimes we offer a work or show what we are developing, and the industry cannot understand exactly the value of that proposition. In Brazil, I don't know here, I'm sure quite, but in Brazil we have low investment in P&D in construction. So if we talk about, let's invest in research and development for construction, the construction companies will say, for what? So this is hard for us to get investment from the construction industry itself, mainly in construction management. In materials and so it's easier, but for construction management, it's not so easy. We need to enhance the skills. We see that we have a lack of standards. We have challenges related to security of data, data protection, cybersecurity. All of these are challenges that we still need to look at when we talk about smart construction, construction 4.0 and so. So this is why since 2015, we are introducing in our work the study of digital technology. Today, I will show you it's a kind of big project that we have. We call this Smart Inspect platform. It's a big project now because along the years, we are adding studies in this platform. We start at the beginning just looking at, okay, drones are very good. Drones have been used in the industry. What we can do with the drones for construction? We started this in 2014-15 when I was at Georgia Tech with Javier Rizari, and we started looking at what kind of application for safety we could use with the drone. But along these 8-9 years, we are expanding our work, adding not only technology, but adding several usability for this. So the Smart Spec is the way that we put everything together. We developed several works and studies from different students, but we are embedding a kind of system, a platform with all the results that we have along this year. So the Smart Inspecs platform is a platform for construction monitoring supported by drones, mobile devices, BIM, and more recently, artificial intelligence. So we have three main areas of development: safety and guardrails, roofs and facade defects and pathologies, and also progress monitoring and terminality. So this is the new face of our platform. I'm sorry, it's in Portuguese. We don't have the platform in English, but this is the new face that we are just renovating our platform, updating, in fact, our platform. The idea of the Smart Inspecs platform, we have three pillars. First of all, it's a project control based on visual data. We are just using visual data in this project. Visual data means image from drone, from cameras, thermographs, that's it. It's a production management based on Lean principles. I told you that my foundation, my basis is Lean production. So when we go to a construction site, we are always thinking about Lean. And also, it focuses on continuous improvement. Why? We want that this platform and these studies could be introduced in the construction routine. We need to incorporate all this work in the construction routine. We are not developing a technology to sell or do. No, we would like to develop something that can be incorporated in the managerial process. In this Smart Inspecs platform, our main focus is to provide data, visual data or data in timely manner. We don't use the term real time because real time for us in construction, it's completely different. I go to a site, I collect some data, I process this and I provide to the manager. It's very difficult for us to be in the construction site and the manager is looking at the data. This is something unreal. We are constructors. We know that the construction managers will not develop their project based on this real data. So we are calling this timely manner data, meaning that the managers will have the information on time for their decision making. So we are using for data acquisition 360 cameras, mobile devices, drones. We are processing this data with a digital platform as the Smart Inspecs, cloud computing, BIM, and we are using artificial intelligence and dashboards in order to analyze the data. And the main three areas, as I mentioned, safety, pathologies, and progress monitoring. All of this that is embarked in our platform nowadays are published in very well-known papers. So we have papers at Safety Science, we have papers at Econ, Engineering, Construction, Architecture, Management, we have papers, we have a recent paper just in press at the International Journal of Building Pathology and Adaptation. So we make a lot of effort to provide something useful for the construction project, but with a very good foundation, scientific foundation. So most of the work that I will present right now are based on these papers. So the first application, safety. This is, let me start the video. What we do, we have here, first of all, we had to develop a protocol in order to collect the data at the construction site. So for safety, we use, in Brazil, we have standards for safety. I'm sure here you have regulations too. So we use the standards that we have in Brazil to be part of our checklist. So the drone, first of all, we collect this data with drone, we fly the drone, we have a mobile device with this checklist based on the safety regulation, and we fly around the construction site using the mobile device, checking the conformity or non-conformity of each of the regulation that are applied for the construction site, because we have several, but it's not necessary to inspect everything because it depends on the phase of the construction. And then based on this data that we collect with the drone takes the picture, we have the mobile device with the checklist, we put everything together in our platform and we provide a report to the manager with this. So this is the software that we have. We put everything in this system. We have a pre-checklist to guarantee that the flight will be safe. We have the safety checklist, and we have the land checklist in order to guarantee that everything is safe. But plus, we don't want just to develop a checklist using with drone. We want to embed this into the safety management process. So in this work, what we develop is how we can incorporate this technology into the production and safety management process. Safety itself in Brazil, it's hard. We are always trying to look at safety and production together in order not to be separate. So Mahara Lima Works tried to incorporate this. So we can see that we need to plan as usual. We need to go to the site, plan what's going on, what's the safety measures that we need to establish. We need to implement these on the site. And then we can use the Smart Specs as, and we remove constraint before in order to guarantee that the safety measures are in place. Then we can use the Smart Inspecs as the check. We used all the information that we have, the safety report, the action plan. This is the example of the report that we can get from the system. For each non-conformity, we have a picture that we took from the site showing the manager, hey, this is the problem that you have. This is why this item is non-conformity. So we provide this, and I'm sorry it's very light there, but in our system, we have a dashboard. So we can have the history of the whole inspection that we have. We can show you are improving, you are not improving, your non-conformity index is better or not, but plus, we noticed that along the visit, some safety problems were not resolved. So in general, the frequency of this inspection can be weekly or bi-weekly, or every 2 weeks, for example. And then we inspect today, and in the next week, the problem is still there. And in the third week, the problem is still there. So we start to put all this inspection in a panel in green and red way and say, hey, in the first inspection, the safety items were solved. During 3 weeks, this is okay, but it's starting to have this problem again. So we are not just providing information about a number, we want that they incorporate this in their planning process. So the idea is to have this cycle closed. So this is one of the applications that we have. As a result, the second application regarding safety, we notice in Brazil, we use a lot this guardrail system. And you can notice that most of our work is related to residential projects. And in the residential projects in Brazil, mainly these low-income projects, we use a system called cast-in-place concrete. So it's fast, but you can produce one floor in one day with everything, but we have loads of safety problems because it's too fast. During the day, they assemble the bars, the formwork, and the concrete in the afternoon, and the second day, we have to remove all these safety guardrails for the next floor. And this process is like super fast. And we are noticing that there are several flaws in these guardrail systems. And then we developed last year, we tried to use the artificial intelligence and the images from the drones to identify that we could recognize automatically these flaws in the guardrails. So first of all, we tried to identify, okay, the algorithm just identified. I can see the guardrail or not. The precision is very high. It's quite easy to say, I have or not a guardrail in the place. Then from the database that we had from these safety condition projects that we collect, we try to identify the main problems in the guardrail. For example, spacing between guardrail elements, no existence or incomplete guardrail system. We map all these failures. We use the database to identify this failure, and then we train the algorithm. We decide to focus in 3 of these problems, the main three problems, because we had more photos and the database were better. We try to develop an algorithm to identify, based on computer vision, deep learning, if the flaw could be recognized automatically or not. So far, this is an ongoing research. We are having okay results. 73% of the probability to identify non-existent or incomplete guardrail, 71% of identification, automatic identification of space between guardrail elements, and 68% of this opening the screen fixed to the panel. What is the problem? The problem is in construction, everything is very similar. You can check these guardrails. They are gray in a cast-in-place concrete that is gray. So most of the time we have the algorithm has difficulties to identify when everything is very similar. This is why we are asking the help from PhDs from electrical engineering to develop algorithms more powerful algorithms that can reach out this. Because in certain level, we have some limitation in this study, so we need this partnership with the guys. So in terms of outcome of Smart Inspecs safety, we implement these protocols in 5 residential projects. Currently, we are developing a huge huge program in infrastructure projects in Brazil. We are building in our city a rapid bus transit and a new bus station for the city with loads of roads and streets. And they hired us to develop this inspection. It's much more to test if our system is okay for infrastructure than to develop itself the system. We are using the same system that we developed for residential. We are having several challenges because it's completely different. It's a very open type of project with different types of works, but it's doing well. We are now finished the 2nd month of this project. We already have 8 inspections, and we are getting improvements in the construction site. They are very happy with the work. Probably we will get a new project next year in infrastructure. So we have around more than 130 inspections and some numbers that I think it's important to tell you. So for each inspection, in terms of residential, I'm not telling about infrastructure, we take around 58 pictures per inspection in a project. We have an average of 70 minutes per flight, and we have an average of, in terms of distance, 1.2 kilometers, means less than a mile radio. A mile is 1.6 kilometer. So it's 0.8 something miles that we can run. We can do everything. We can collect the image with the drones. We can process the image, and we can send the report in 55 minutes. We can do it's a whole project. In general, our project is around 6 or 7 small towers, like 5-story towers. So we can do this in 55 minutes. This is timely manner. This is not real time, timely manner. In less than an hour, we can provide the safety manager, the production manager, with information about what's going on in your site in terms of safety. The question that since the beginning, people ask us, hey, how about how the workers feel about the drone in the construction site? This is a recurrent question. And then we have data for this too. So since the beginning, we collect information. We are in touch with the workers all the time. And we collect information about their perception about privacy invasion, distraction from work, concern to hazard of falling or collision, and support improvement of site condition. So these are the 4 questions that we ask to the workers during our time. And you can see that in general, they feel that they have a kind of low perception of privacy invasion, distraction, and concern to hazard to fallen. But they feel that this method support a lot the improvement of the work in a scale from 1 to 5. So we have these good results, and in Brazil, we don't have this problem of privacy invasion. Sometimes in other countries could be more important, but in Brazil, it's not a big problem. Another very good outcome of this work, in 2021, during the pandemic, we developed a similar system for the industry. So in a big project, innovation project, 5 construction companies invite us to develop this system for them. So we have our system, and we develop another one for these 5 construction companies, so they can use in their own way. So this is a huge achievement for us, because we are just putting our platform to the industry itself. Okay, the second application is the roof and facade defect pathology. We had similar approach to this thing. I will speak a little faster. To the roof, we got a demand from the construction company that we are partner. They asked us, hey, we are having loads of roof problems in our buildings, not during the construction, but during the use. And because of the guarantee of the construction project has to provide to the users, some of the problems were credited to the construction company and not to maintenance. And then they asked us to find a way to use the drones and collect this information in a faster way, in a more timely manner. So we started this work collecting data from 167 roofs of this construction project in use. We identified the main problems that we could see in the roofs, and we established a small database for each problem. And then we did the same of the guardrail. We identified the problems. We start to use artificial intelligence. We develop an algorithm to identify the problems. You can see the square here, another square here. We train and test these main pathologies. We use also data augmentation to improve our database because we had problems. And then we got the results. In the end, we could identify through the algorithm 11 of this pathology. So we can recognize automatically 11 of this pathology, and we embark this in our system. So now we can go to a construction site, fly the drone, collect the image, put all the image in our system, and automatically we can recognize 11 of the pathologies automatically that we had identified, and the rest that we cannot identify automatically, we use manual inspection. So this is something that we improved a lot, the maintenance process of the construction company that is our partner. This is an example of this. I will show you the time that we do this. It's very fast as well. So similar, we did this for the facade. So we have the roof, we have the facade. We develop a protocol to collect the data. We identify the pathologies that we can see with the drone. We can use the algorithm for this. We have the result here of the probability of recognition during test. And then we also incorporate this in the construction routine. Here, the facade is during the execution. It's not after, it's not in use. Because in this work, we want to solve the problem during the execution. So we are adding this work into the quality management process. And we do this, we provide these reports to them with all these squares in different colors that is related to the pathology that we could identify automatically. For example, the lack of facade, the reinforced exposed, the segregation of concrete and the cracks. And also we try to incorporate this to the quality management process during the execution phase. So this is always our idea. Develop a method and incorporate into the construction process. Some results, some outcomes of this thing In terms of roof, we collect data in 13 projects, 211 roofs. We have not enough database, but we have a database of more than 3,000 photos, and some of these with the problems. And in terms of the facade, we developed this project in 3 projects, 90 towers, and we have this database. Again, in terms of average time, when we embed in our system, the roof is embedded, the facade is not embedded at the moment. We are working on this. But we can provide information in 35 minutes. We can fly the drone, 26 minutes. The project is around this, 6, 7 towers, small towers that we can collect data. We download the photos in 1 minute. We check the work in 2 minutes. And the automatic process report is generating 4 minutes. So in 35 minutes, we can collect the data, process the data, and provide the report to the managers. So this is very good for us. In terms of facade, we are still doing manually because it's not embedded in our system, but our expectation is, because it's the same process, when we put in our system, we will reduce this 40 minutes of manual thing in around something like that, 40 minutes, 45 minutes. Our goals is less than an hour, let's do it. Can be 60 minutes, there is no problem. There is no rush. 45 minutes, an hour, there is no difference in construction. But our goal is to develop all this inspection, processing, and information in an hour. So we can have this done. In terms of impact, we are improving quality of roof and facade inspection. We have this faster data collection and data recognition and reduction of accidents. Imagine for roof and facade, one of the problem is how to put people to inspect towers, roof, and facade in a safe and fast way. It's very hard. The drone can do this easily. And the last application is the application in progress monitoring. We started this in 2018, and still we have a lot to do in this area. We start to developing this overlap of cloud point. We can fly the drone, we collect the image, we process this, and we provide a cloud point of the building. And we overlap this in a 4D beam. And then we can provide indicators about the progress of the project. We have 2 problems. First problem, still we have several projects without beam. Second problem, still we are having 2 manual activities to overlap the point cloud and the beam 4D. We need to develop things. I know that Manny in Illinois, he's the guy. We try to follow him a lot. I know he knows how to do that, but we are still working on this to have our own solution. But more than this, when we start to develop this work, when the construction is outside, we can use a lot this strategy. But as soon as the activities start to be inner the building, we cannot use a lot this strategy because we cannot capture this. Then, so here we have some data. In August, in April, we could see, this is the indicator that we develop, work progress visually measured. In April, the project was very open, so we could see a lot outside. And by the time that the construction start to be developed inside of the buildings, we could use only 33%, we could see only 33% of the project with our methodology. And then, okay, it's very manual, there are so many problems and we cannot see everything. Then we decide to use the 360 camera to see if we could add value to the internal activities. Yes and no, I can say. 360 camera, at the beginning, we had the hypothesis that we could develop point cloud as well, and put together the external and the internal point cloud and put together an overlap with the beam. It doesn't work very well. It's very time consuming and we have different things. So it was one strategy, but it's not working very well. Then my student decide just to compare with what's going on inside, with what we could see with the camera 360. Still a lot of manual work. But one thing that I can say that is very nice, we can use the camera, 360 camera for the unfinished work. For example, it's not very good for measuring progress because we still need to see the beam and the photos, and it's manual. But the applicability for unfinished work to see what's going on, it's very good. So maybe we can use again the camera 360, not for progress, but for the purpose of quality, because we can see better the unfinished work. But progress is still, we are working on this. These infrastructure projects want us to develop something in progress monitoring. For them is very important. We are having a hard time to do that. We will work, probably next year we can have a solution for this. But so far, it's something that we need to develop. Okay, I'm about to finish. So to finish the presentation, after all this work that we develop, we noticed that the construction project still have problems to incorporate all this technology because of process, because of infrastructure, or any other thing. So this is why Luara, 3 years ago, I approached her and I said, hey, what about to think about a measurement system to measure how the construction project are in terms of this digital transformation, how we can measure the evolution of this project. What about this? And Luara, okay, let's do it. It's the challenge, you know? We have a vision and we ask the PhD to develop this vision. Luara is in, and then we start to develop this maturity measurement system for an intelligent construction environment. So the idea is, the question behind is how the construction industry can be positioned towards digital transformation. And then we are using these maturity models as a tool to assess the effectiveness of the system. So we are trying to develop this maturity measurement system. Luara, I'm sure she will have time to explain to most of you if you are interested about this model. But the idea is to develop measures that can cover all of these dimensions. So we are thinking that construction is a complex system. We have several elements: production process, digital technology, infrastructure, culture, human resource, and we need all of these to get performance. Then what we are trying to understand is, okay, is there a measure? First of all, these dimensions are okay. The construction managers believe that these dimensions are what we need to measure. So this is why she's doing a Delphi study to collect this information. So after that, we'll put weight in this dimension, and then we can establish measures to identify the level of maturity. The level of maturity that we are thinking is about 5 levels. Level 0, we are calling readiness level, means that this level position the construction system with the basic requirements to evolve into an intelligent construction environment. Then we have a digitizing level, then an embedding level, digitalizing level, and semi-automating level. So we are trying to develop this measure and put these measures in different levels to understand the evolution of this constructions project into this intelligent construction environment. So this is Luara's thesis that we are developing right now. Hopefully next year, we will get much more results, final results. At the moment, she's assigning weights to the measurement, as I mentioned, proposing the indicators, implement the measurement system. The idea is to implement in 4 empirical studies, and then finally evaluate the system to see if we can say in the end, okay, project A, you have a level of readiness, so you need to work a lot in order to be towards digital transformation, and then she can provide guidelines for this kind of project to achieve level 1, 2, 3, or 4. So one thing is to make the diagnosis in which stage we are, and then we can provide some guidelines to achieve level by level the maturity of towards digital transformation. So basically, this is the idea to present 12:30 Jesus Christ, and now we're talking. These are the impacts of our work. We are having impact in the industry, in the academia, with awards, with chapters, magazine. So we are having very good results based on this. And for future opportunities, we need to advance in the understanding of this maturity measurement system. We need to advance in digital technology integration. So we are using drones, artificial intelligence, camera 360, but also we have a new project concerning digital twins. It's a project funded by our national agents, and we have some PhD students working on this too. And we are focused, again, production safety management, but integrating not only drones, but IoT, artificial intelligence, BIM, and blockchain. And finally, all of our work, we try to assess the solution, and we need to refine all the time these constructs in order to provide solutions that impact the management process in terms of quality of decision-making, system performance, user satisfaction, and generalization and scalability as well. This is the GETEC UFBA team. My acknowledgement for all of them. Without the professors, PhD students, master students, undergrad students, postdoc, we cannot do all of this. So my sincere acknowledgements, and I appreciate very much the work of my students. Some of them are watching online, and these are our social media. And if you have any question, please, I'm here to try to answer. Thank you so much.
Well, thank you very much. That was a very interesting presentation. I'm sure we have a lot of questions. So let me look around here, and then I'll also go online to see who is online that would like to raise a question. So let's have it from here, from the audience present here. Any questions? Yes, go ahead, please. You can press the button there. Yeah.
Thank you very much for the amazing presentation. It was really comprehensive, seeing that what research and everything. There was a time we were talking about data augmentation. Sometimes when you don't have enough data set for your database, you talk about data augmentation. I wanted to ask how effective is the data augmentation in actually improving the learning of the systems, and how often do you do it? So that's one of the questions I have. Yeah.
Okay. I have good and bad news. Good news, for example, for this roof worked very well. But for the facade work, doesn't work very well. So we are still trying to understand. I don't have the answer, it's very good or not, because it depends on the database, depends on the quality of the photos, and depends on how different is the problem. For the roof inspection, we had more different problems with different colors, so it worked better. When we try with the facade, it was quite a disaster. The result was not good. Alison is watching me, and probably he knows that, because it didn't prove anything. But because it's everything gray with the facade, we are talking about concrete and problems in the concrete, so we had more difficulties. So I think it's mainly because of this. The guardrail, we didn't try, but I have these two experience, and I can't say that is good or bad, but depends on the quality of the images and the type.
Any other questions? Well, let me check with our online audience. Yeah, do you have a question?
Yes.
Let me check with our online audience quickly, and then see if they have any questions. Anybody online wants to ask a question, please open your mic and go ahead and ask. Yes, Evan Rich, go ahead, please.
My question for today is very simple, and I have the presentation was very great. I really appreciate and enjoy it. But the question I have is using drone technology taking pictures on site. I want to ask the research team, did they encounter any natural disaster, like there's like a strong wind, and how did they what measure did they take to solve the problem?
Okay. I'm not sure if I understand very well, but you are asking me if how the drone works when we have strong wind, for example, or it's this, or if it's can be used for disaster something.
Yeah, just that. If there is a strong wind, how do you?
Okay, we cannot.
Yeah.
We cannot. With the DJI that we are using loads of DJI drones that's very light, less than a kilo pounds. It's like 2 pounds, something like that. So if we have heavy wind with these small aircraft that we use, it's not possible. But at the beginning, we had problems with some wind. It's okay. The first drones we had the camera shake a little bit, but nowadays the drones are much improved. So the quality of the image can be okay with some wind, but strong wind, it's not possible. But definitely there are several other types of drones. It's not the one that we use because we want the most affordable ones, because needs to be incorporated in the construction site. If we decide to buy a very expensive drone, will not be enough to incorporate. But no, we have trouble with this.
So we have a question coming from the online audience, and Professor Dulcie Abraham writes a question that, of course, excellent presentation, but if the drone's data indicates imminent danger, how would that information be conveyed to those at the construction site?
but okay, in terms of safety, got it. No, I was thinking about the danger of the use of drone. Well, we have the following procedure. When we are collect the data, in general, we have two persons, the pilot and the observer. And together with us, if the observer is not the safety manager or technical, we ask for the safety personnel to follow us during the inspection. If we have an immediate problem identified, we just warn the safety personnel and say, hey, look at this and solve the problem. We don't wait for the report. So during the inspection, we are always, the idea of this proposal is to have a pilot and a safety manager together, safety personnel together. The safety personnel can be the pilot or can be the observer. So he is the responsible to see the condition, but if there is an imminent problem, he needs to stop and solve the problem. This is the way that we do the inspection. And it's working quite well in this sense, quite well.
Thank you, Delcy, for that question. Majid, you have a question?
I have a question about
in general, just the photos or videos. LiDAR we are not using right now. We are planning to use thermal images, but we don't have the drones with or LiDAR or thermal, just the photos and the video so far. But it's possible, definitely.
Yeah, so I have a comment. So I'm suggesting, like, if you are planning, if you use LiDAR, it would help a lot. Like, as you mentioned in the guardrails, it's difficult to distinguish if there is some similar features around the guardrails. But if you use LiDAR, you can detect, because you can see the spacing or the depth on the image. So you can distinguish between the two.
Sure, for sure. We need to try it. We need to buy a new drone with LiDAR. But definitely, we thought about this and we need to have this equipment. Great, thank you. Thank you so much.
Yes, thank you for the very nice presentation. I was wondering, in your analysis of worker perception and disruption to the work site, had the workers been trained in advance about the drone and the inspection purpose and why the drones were being used?
Yes, for sure. Thank you for the question. This is excellent. In general, we have these DDS meetings, the meetings at the early morning that safety personnel or put all the workers together to say some few words before to start the work. So this is the kind of training that we have. It's not a training like put everything in a room and say what is the drone, but during this safety daily routine that we have in the construction, we inform that, okay, this day we will have the drone flight, and the idea is not to, it's not punishment. The drone is there just to collect more information for their safety. So in general, we have this daily safety routine, but also when we are for a long time in a project, sometimes we are invited for more meetings to provide the data, to have a kind of a close relationship with the work, showing our work, show our photos. One of the work that we develop, we try to incorporate into the safety routine. We used to put a board with photos with good practice and opportunities of improvement in order to engage the workers even more in this process. But yes, we need to be in touch with the workers and train and warn them that we are using the drone.
Great, thank you very much. Yes, go ahead.
Okay. Thank you for the presentation. It was a very comprehensive presentation, like Toby mentioned. I wanted to ask if the data that you collected using your drones was used for claims or dispute resolution or something later on by the companies to defend themselves or.
I try not to be in this field, but it's possible. It's possible because we have the photos and the images, sometimes videos. And I remember once, Javier is there, Javier was online, and we were at Georgia Tech, and it was a kind of silly thing about, not silly, but it was kind of simple things about trees. And then we took pictures 1 or 2 months later, and then we collect the data. And then 2 months later, somebody asked that, oh, the constructor just removed trees that not supposed to be removed. And then we had the data collect 2 months ago with the image, and the trees were not there. So it was not something that was the builder. It was not there. So this is a case of this. This is something that we can do for the roof inspection. What we can do is to identify that if the problem is a executive problem from the execution, or if the problem that we are seeing, it's because the maintenance is not okay. Because sometimes we have problems due to bad execution, but we have problems concerning maintenance as well. And this is something that we can use the photos to make clear to administrators. Oh, look, we have here, we are seeing that the maintenance is not okay. It's not the responsibility of the builders. But yes, for sure, we can do that. I try to avoid.
Thank you for those questions. Do we have questions coming in from online? Anybody interested in asking a question? Well, if you do, please open your mic and go ahead and ask a question. In the meantime, let me see in our audience here, do we have any questions coming from here? Well, so as I always do, let me ask the last question. And Dayana, a very interesting presentation indeed, and you can see from the number of questions that we got, everybody is looking at from a very unique perspective. You had mentioned initially about Industry 4.0, Industry 5.0, and what I was wondering was that how do you plan to take this further into implementing Industry 5.0 concepts, particularly human-centric, sustainability, resilience, and so on?
This is a tough question. Always the last one is the more comprehensive one, but it's okay. Definitely, our idea is, as I mentioned at the beginning, technology itself is not enough. For sure, we need to, when we think about human-centered, we need to put the people, the managers, into this process to be part of this. So when we think about Industry 5.0, definitely we need to put the people in the core, in the center of this incorporation instead of the technology. Also, when we think in terms of sustainability, I think when we talk about less accident, when we talk about less time and less waste time, and so we are talking about sustainability as well. So it's not only about productivity, but it's about to see the system. In terms of resilience, one of Rose, she's postdoc now, but in her PhD, we try to link resilience, how the technology and the drones could be integrated with this resilience engineering approach, how we can collect this information and use this information to adapt our system. So I think we can use these concepts of resilience, sustainability, people-centered in this way. We are already using, but we need to highlight this, because so far technologies they highlight. We need to put the technology as a tool, more as a tool, and people more involved, and try to collect information that can provide, can inform that we have impact in terms of resilience and sustainability as well. I think something like that.
Thank you very much. I think this has been a very interesting seminar. Please give her a big round of applause. I want to thank Professor Dayana Costa for being here today, and of course for all of you in the audience to be here, as well as those who are online. And Javier, we see you there. Thank you for joining in, Professor Abraham. Well, so thanks everybody for joining in. We continue with this series next Friday again. We have another distinguished speaker coming up, so please stay tuned. Thank you very much.